Example 1. Design a V-belt drive to transmit the power from an AC squirrel cage motor rotating at 1440 RPM. Alright, the motor rotates at 1440 RPM and rated at 11 kilowatts to a fan rotating at 725 plus minus 1% RPM. So that's a driven speed, okay, and the item to be driven by the AC squirrel cage will be a fan. Centers are to be near to but not more than 750 mm, 0.75 meter apart. Alright, that's the two pulley. And the driven pulley is not to exceed 250 mm outside diameter. Alright, so that means the question is talking about the outside diameter of the driven pulley should not be more than 250 mm. The drive, alright, is required to run a minimum of 18 hours per day. Sketch the design layout. Okay, so let's move on. So these slides, we will talk about the design power. We will determine the design power and also select the proper V-belt cross section. Alright. Before we proceed, please get ready the appendix. It can be found on ME2014 Blackboard Home-Based Learning Resources. Turn to HBL folder under Notes and Appendices. I'll give you a few moments here to get ready the appendix before I move on. Okay, so let's move on to this problem. This is the design layout where you have a driver, an AC squirrel cage motor, alright, driving a pulley, unknown diameter, pitch diameter. The rated power is 11 kilowatts and is required to operate at 18 hours a day minimum. Okay, so these are the information that's needed to identify the belt section. Of course, the driven part will be a fan. In this case, the question stated that the outside diameter of this pulley is not more than 250. Okay, the outside diameter of the pulley is the largest diameter. Okay, and we are more interested in the pitch diameter, which is slightly smaller than the outside diameter. And this is the center distance. Okay, the center distance should not be more than 750 mm, right? And of course, the rotating speed is 1440 RPM at the squirrel cage motor, and the fan should rotate at 720 RPM plus minus 1% based on the questions. So, how do we select the belt section? We know that it is okay, if you go to your appendix, go to page A1-2, suggested service factor for V-belt drive. So we need to determine the service factor for this problem. So we have X and Y. So okay, the vertical and horizontal columns to fulfill. So based on the necessary information, just identify which column is what we want. So of course you look carefully, the types of driving units, that means what type of motor is that. The question referred to is AC squirrel. Alright, it's a AC. Okay. Squirrel, SQUIRREL. Okay, so in this case, you look through, you see there's AC motor here. Okay, give me a minute. There's AC motors, right? But then again, over here on the left hand column, there's a normal torque squirrel cage. So it's AC motor squirrel cage, right? So you AC motor, there's no squirrel cage, but high slip, another type of driving units. So in this case, we are very interested in this column. Okay, so we ignore the right. Okay, the question told us that we have a AC squirrel cage motor. So this is the one. So how many hours? If I'm not wrong, my memory serves me correct. 18 hours minimum. So over here is 3 to 5 out, 8 to 10 out. So 16 to 24. So in this case, I'm AC squirrel and come to this column. Now, which row should I choose? So in this case, let's go to the left hand side, look at it. Types of driven machine. So the type of driven machine will be a fan, right? A fan. So in this case, if you look at the question earlier, if it's 11 kilowatt and you convert it to horsepower, it will be something like 14.7, right? If you don't believe me, you go back to your example, refer back to your notes. Okay, the notes also have the example. All right. So you can turn to your unit 7 notes. Okay, there's the same example as shown here in the slides. So why we choose this second row is actually the fan, the driven machine's fan. There's another fan here also. Can you see on the top one, the first one, fan, up to 10 horsepower. In this case, our fan in this question is 14.7. So okay, so you look carefully which particular, okay, choose the closest or the correct type of driven machine. So in this case, my service factor is 1.3. Okay, 1.3. In order to determine the belt sections, right, we need to determine my design power. So what is design power? In this case, my design power is equal to rated power times service factor, which I determined earlier is 1.3. And the rated power is from 11 kilowatt. I convert it to horsepower is 14.75 horsepower. I multiply by service factor, it give me 19.18. So this is the design power. So if you were to use the appendix, turn to page A, 1-3, cross-section selection chart, cross-section belt. Alright. So in this case, which type of belt section should I use? A, B, C, D, E. It will be determined by your design power. Okay, your design power here. And your RPM of fastest shaft. So in this case, how do we know which section? Okay, so now, what is the shaft, fastest shaft RPM is 1440. So if you look at your cross-section selection chart A1-3, 1440, the closest will be here between 1200 to 1005. So well, you can just mark from there. Then what is the design power? In this case 19.18. So it's some behind this 20. So you can just mark it up, you cross, and the intersection point will tell you that the belt section selected would be B. So it's a B belt in this case. And the dimension of B belt is 17 by 11. Okay, A is 13 by 8, C is 22 by 14, D and E will be getting bigger. So the bigger the area, the you look at it, is actually the more power rating it can withhold or withstand. Alright? Okay, let's move on. Alright, we have completed the belt section part. So the next we will go into pulley sizing to determine the pitch diameter of the pulleys for this question.